Hello, this is Kona, and we're going to go through some examples of standardized scores, or Z-scores, and hopefully you've already looked at the different example information, so this is just kind of me going through how to actually find some of this information. So first of all, to find the Z-score, we take the value, the given value, minus the mean, over our standard deviation. So for this very first example, you take the ACT test and the SAT test. You got a 26 on the ACT and the 620 on the SAT. College that you apply to only needs one score. Which do you want to send? That is, which score is better, the 26 or the 620? And then here's the given information for the mean. So remember, this is mean equals 18. There's our sigma, standard deviation equals 6. And our SAT, we've got our mean of 500 and our standard deviation of 100. So for our Z-score, for the ACT, we would do 26, which is right here, our 26, minus our mean, which is 18, over our standard deviation of 6 to get 1.33. And the Z-score for the SAT would be our 620, which is the score we got, minus 500, which is the mean, over our standard deviation of 100 to get 1.2. So remember, these are standardized scores, so what we've done is just standardize these two scores so we can actually now compare them. And so now looking, which one of these is higher? So which one would you want to send? Well, the ACT of 26 is actually higher than the SAT score of 620 when you standardize them. So you would want to send your ACT score. So we can also transform a Z-score back into a raw score if we know the mean and standard deviation of the original distribution. So here is the actual algebra. So if this is how to find a Z, then to find the value, you would just kind of manipulate it. So for this one, we're trying to find the value, so that means we would multiply standard deviation times Z. It's standard deviation times Z on both sides. So that way we could cross it out on this side. Then we'll be left by value minus mean equals Z times standard deviation. For that one, we would then add the mean on both sides, so that way we could cancel it out on this side, and we get value is equal to Z times standard deviation plus mean. So if you suppose that you know somebody else who said they got 2 standard deviations above the mean on the SAT, how would we figure out the score? Well, we're just assuming the mean and the standard deviation here. So you would plug those values in, and your Z-score, so up here, is the 2. So you've got X is equal to 2 times 100, which is your mean, plus 500. I mean, not your standard deviation, I'm sorry. 2 times your standard deviation plus your mean of 500. And that's the 700. So if someone said that they got 2 standard deviations above the mean, you would know that their score was the 700. Okay, so moving right along, for a normal distribution. So for a normal distribution, remember that normal distribution is that bell-shaped curve right here. 34.13% of the scores will fall between the mean and 1 standard deviation from the mean. And that's the -1 and the 1. So there's your 34.13, and it's also 34.13 over on this side. 13.59% of the scores will fall between 1 and 2. So here's the 1 and 2. So that's the 13.59, but it's also in the negative between -1 and -2. That's also 13.59. And then 2.28% of the scores will fall between 2 standard deviations and 3 standard deviations, and that's this little chunk way out here in the tail and also in the negative tail. So important tool that we use is the unit normal distribution. In this distribution, there are a bunch of Z-scores proportions for the standard normal distribution. So in other words, this unit normal distribution allows you to figure out the area under the curve and thus the probability of sampling every position on the curve. So the 5 steps define the probability of something. So we sketch the distribution showing the mean and standard deviation, sketch the score in question, being sure to place it on the correct side of the mean, and roughly the correct distance. Read the problem again to see if you need the probability of getting a score greater than or less than. Shade the area. Then step 4 is calculate the Z-score or other score depending on the problem. Step 5, use the probability distribution calculator to find the correct value. So let's do this. So example, find the probability for the following problems. If the IQ scores have a mean of 100 with a standard deviation of 15, what is the probability of having an IQ of 70 or less? So remember our steps, sketch the distribution showing the mean and standard deviation. So I sketched this out, put our mean of 100 in, and I didn't show the standard deviation, But you could show the standard deviation. In all actuality, I would just include for this one the mean. So then sketch the score in question. So our score was a 70. So if 100 is our mean, 70 is going to go over here on the left. So I put the 70 in. Then read the problem to see if you need a greater than or a less than. Well, this is an IQ of 70 or less, so we would shade the less than because we want to find this area underneath this curve. We want to find all the area less than the 70. So the next step is finding the z-score. So we've got our 70 minus our 100, which is our mean, over our 15, our standard deviation. That's just the formula that we used from the previous page. And we get a -2. So the next step is using the probability distribution calculator. So for the probability distribution calculator, I'm going to actually come back over here, and this is the week 6 information, and we have probability distribution calculator. So we're going to go ahead and click on that, and you will see that it's got z-score right here. So we're going to enter in a -2 and click calculate. And what we're going to get is the left side, right side, and both sides. So this is the area on the right side, or the left side, the right side, and both sides. But the question is, which do we need? So let's pull this back up, and we use with the probability. Well, remember, we want the left because we're looking for the less than that 70%. So if we come over here, the left side is this value right there. And so that's the value we want because, and this is why it's really important, and that's why I say draw the picture, because by drawing the picture you can easily see you want the less than the left side. Because remember, less than is the left side, more than would be the right side. So you know that our area is the 0.022750, which is equal to 2.2750%. So for another example, IQ scores of a mean of 100, standard deviation of 15. What's the probability of having an IQ of 130 or above? So here's our sketch. We put our 100 in because that's our mean. Then we want 130. That's our number we're looking at. So 130 is higher than 100. So we're going to put the 130 in right there, or above, and we're going to shade it all this way because that's our above part. We then find our z-score. So z is 130 minus 100 over 15. Our mean, our standard deviation, and we got 2. We then go to our probability distribution calculator, come down here, we put 2 in, click calculate, and we get our left side, our right side, and both sides. So which side do we want? Well, we're doing above this number, and above is a right side. So over here, right side is this value. So back here, it's this, which they are the same. I just flipped one side and the other, but it's still, you still get the same idea of how you would find that. All right, so if IQ scores have a mean of 100, standard deviation 15, what's the probability of having an IQ score as extreme as 120? Whenever they say as extreme as 120, know that you're going to use the both for the probability calculator. So for 120, we're going to go ahead and put that in. So we draw our picture, put 100 in, put 120, and we're going to find the both. But first we have to find our z-score. So 120 minus 100 over 15 is your 1.33. So then we come over here and 1.33, calculate, and remember I said we wanted both. So down here. Sorry, not down here, but back to here. So this is where we get our both. And why we want both? Because it's as extreme as 120. So it could be, we're not 120 or more than, it's as extreme as. So just whenever you see that as extreme as, know that it is both. So then working backwards from probability to find a value. So here are the steps, which are pretty similar here. So basically, find the value given a probability. So what IQ score do you need to have to be in the top 5% of the population? So here we've got, remember, still the same mean of 100, standard deviation of 15, remember, right? So we sketch this out, put our 100 in for our mean, and we want to be in the top 5%. So that top 5%, first of all, we know that we're going to be over here on the right, and we know right here is the 0.05, and that's our right side. So for that one, we know if we do this, then what we have to do is use the probability distribution calculator to see what our z-score would be. So we know it's 0.05 on the right, so we come over here and we have z left, right. We do 0.05, calculate, and we get our z-score. So then we come back over here, and there's our z-score. We then plug our z-score into this formula, and remember this formula came from back here. Is that it? Where was that? Oh, right here. Yep, so that's where that formula came from, because that's working backwards. So this way we're working backwards, but so to find our value, we then take that z-score times 15, our standard deviation, add it to our mean to get 124. So to have an IQ score, what IQ score do you need to be in the top 5% of the population? 124.67281. So what IQ score would you need to be in the bottom 10%? So we put our 100 in, and we know we're in the bottom, so we're in that tail part. So we go ahead and put this in, shade it, and we know this is our 0.10, and we know it's on the left because it's the less than. So then we come to the probability distribution calculator, left, 0.1, calculate, and we get a z-score of negative 1.281552. So that's where that z-score comes in, and then we plug that z-score in, times 15 plus 100. So to be in the bottom 10% of the population, you would need an IQ score of 80.77672. So I know this video is probably longer than some of the other ones, but I hope you still found it useful. And if you have questions, let me know.